Let's wait for it to start recording. When it turns red, yeah. So now it's recording. So welcome to today's session. We'll be explaining practical 6, right? So I'll explain things like arrays and functions, how to pass arrays inside functions, because we did talk about functions, right? And header files, yeah, also header files. So I'm going to open code blocks. I will make my own example, right? So code blocks. I'll use my own example, right? So I don't know what example am I going to use. Okay, I'm gonna have an example whereby I have an array, a fixed sized array, and because remember I'm not allowed to give you the memo for the prac. I'm only allowed to give you after you've attended the prac session. That's when it's allowed for me to do that because it's not fair to you guys. You won't be getting the help, right? It's not good to give someone the answer. It's better to explain or give them a different example, then they have to go and figure it out on their own. So I'm gonna just say this is practical 0, I don't know, sample, just a sample of how you approach practical 6. Then I'm gonna say manage sources. And with our sessions, we're gonna have to shift them to 7. Yeah, let's say 7 to 7 because most of you guys won't be at rest at 6, so at least 7. So it's gonna be 7 p.m. But I'll announce in the group. Let me change the settings here a bit because it's going to allow people to enter the meeting without muting them. So I want it to mute automatically when you enter the meeting. Okay, that's sorted. So I'm gonna make an example, right, with arrays. But before we do that, let me explain what arrays are, right? So I'm going to do this. I'm going to go to draw.io. Then I'm gonna create a diagram. Then I'm just gonna demonstrate arrays. So it's going to be a blank. I'm gonna call it arrays. Arrays. So we're going to explain arrays, right? So the way arrays work, it's basically multiple variables. But then those multiple variables or multiple boxes. Remember, okay, we're still going to we haven't covered the variables yet in our intensive revision, but let me just explain a variable. So a variable, you can think of it as like a box. And then when you give the variable name, it means that that name of that variable is the label on the box, which basically defines what that box stores. So for example, if I have a variable that's called let me see, toys, right? I have a variable called toys. That variable, in a way, it acts like the label for that box, so that so that in our case, the computer doesn't care. The computer works with addresses. We just use the label so that it's easier for us to know what that variable stores, or basically what that box stores. In this case, I said it's a box full of toys, right? Then we can also specify what we call a data type. So the data type it basically specifies what type of things are there, right? So the label, it's sort of like how do I put it? Okay, let me make a different example. The variable, right? Let's say the variable is called sunlight, right? The sunlight liquid, right? Or sunlight washing powder, whatever. Then the data type would be what that thing is, right? Or what type of thing it is. So it's a washing powder. So that will be what the data type explains. So when we create a variable, we're creating a box. Then the name of the variable, it's like a label on the box that tells us what's inside the box. Then the data type describes the thing that's inside the box, what type of thing it is. So for example, sunlight, if you remember there's different sunlights, right? There's sunlight bar soap, the bar soap, right? Then you have sunlight liquid. So there's different sunlights, right? So the variable name would be sunlight. Then the data type would define what type of sunlight, right? In this case, we're referring to the washing powder, the washing powder that you guys use to wash your blankets address or your clothes address. That's the washing powder we're talking about, which is the powder form. So this is how it's going to look inside the computer. Then you put inside the things that belong to this box. The box says that you can only put in sunlight, and the type of sunlight you can only put in is a washing powder. So that means this box, if you try to put in, for example, a spoon, that's when C++ is going to show you an error if you try to put inside a spoon here, because the box says, no, we accept only sunlight, and the type of sunlight we accept is a washing powder. So even if you try to put sunlight liquid, it was going to crash because it's not the type of thing this box expects you to put in. So that's why if you go inside C++ and you create a variable, let's say int x, this means that the label on the box is x. The type of things that should go inside that box is integers. If you still remember in high school, element of z. So that's what it means. So integers. So if you try to put a double, which is basically numbers with decimal points, if you try to say 3.4, yeah, C++ starts shouting at you because that's not the agreement you guys had. Why is it not? This is weird. This is why I don't like C++ sometimes. But then it's not really C++, it's the IDE. Let me check. Let me just double check something here. Yeah, I did put it. Yeah, it's the IDE. This should have crashed. I don't know why it's not crashing. Yeah, it should have crashed. C++ does that, especially code blocks. Code blocks is very unreliable. But this is wrong over here. This is very wrong because anything, the moment you see a dot, that's a double. So you're trying to put a double into an int. So there's a problem there. Or let's use a string. Maybe it was gonna complain more if we or yeah, let's say a string. If you try to put a string, maybe it's gonna complain. Yeah, but C++ is weird. I don't wanna lie. C++ is very weird. It should have complained with the double. I don't know why it's refusing to complain. So just be aware of those errors. Sometimes C++ does not give you the error, even though there's an error. Especially code blocks. Not okay, let me not rephrase that. Not C++. The code, the IDE itself, it might not give you an error even though there is an error. So be very careful of such errors. So you see what's happening is that the type of thing here that I'm trying to put inside this box with a label is not an int. So that's why it's showing me this red square over here. So that's very important to understand about variables. So now we understand variables that we give the box a name. We understand that a variable is just a box and we give it a name. And inside the computer, right, each of these boxes, they have an address. So they're stored somewhere. And the address is in hexadecimal. Go revise the slides if you forgot hexadecimal. You recently wrote semester test one, so you should know what hexadecimal is or is all about. You don't need to know the numbers. The numbers are generated randomly by the computer. So each variable has its own address, right? Or each box is stored at its own address. Then that's when you start to understand things like pointers or whatever. But then in this case, it's not really important to understand the address, but just know each box it's stored somewhere at a specific location. Just like remember, computer mimics human beings, right? Because it was made by human beings. Since everyone stays somewhere, your rest, right? Your accommodation has an address. So you stay at that address. So the same logic is applied inside computers. So every variable, even functions, they have their own address. You learn about function pointers, basically creating a function that stores an address of another function. Hey, it goes down. The first practical of one COMSA 1B, it just gets worse. Just know. And now Dr. Stung is in the picture. It just gets worse. So you guys should start attending classes, or else you might make it this semester, but next semester, trust me, we can bet my I don't know, we can bet my YouTube channel or something. You will definitely fail if you come with the same attitude. Then with arrays, right? You can imagine arrays is like we have multiple boxes. So basically multiple variables. So it's going to be tough to make this diagram, but let me try to be quick. So you can imagine this is we call in the proper English term for it is called, they say that it's stored in contiguous blocks of memory, meaning one after the other, right? Or one after another, which is basically sequential anyway. So they mean sequential, but they use the word contiguous. Yeah, English. So yeah, just be very careful of that word when you see it. So you can imagine that we have multiple boxes, right? And each box is stored in a specific position, right? We have what we call position. It's like a queue. You are in number one. This is number one, first in the queue. This is number two in the queue, the second person in the queue. This is the third person in the queue. So it's sort of like that. And then you would have your labels on each box, but that's not the point. I'm just trying to demonstrate the arrays. I don't have to give them labels. So let me do this. Let me increase so that is visible. Yeah. Okay, I can delete all of this. Yeah, there's quite a lot to explain. That's why I was very worried if I'm gonna have enough time. So if you're in a queue, right? Remember, like I said, computers they mimic or they copy human beings. So in a queue, okay, you start counting from one. You say this is the first person. This is person number one. Then person number two. Computers they work in a weird way. They start counting from zero. I'll explain why I start counting from zero when you get to pointers. That's a very complicated topic, and I have to make use of a lot of diagrams. I have a way of making things simpler by the way I explain. It shouldn't be a problem to explain, but to understand it's a very complex topic. So I hope most people will attend when you talk about pointers. Or else after that, it's just gonna be hell. ComSci 1B is not a joke, guys. Trust me. Don't take it light. And it builds on what you've learned this semester. If you didn't learn anything this semester, just know you're gonna be getting a lot of zeros second semester. So arrays, they start counting from zero, right? So they are zero based. We call it zero based. So when you say in this array, okay, so this array, this whole array, right? It has one name. You can give it one name, right? So we can call it, okay, let me delete. Let's say this array represents a person's marks, right? This whole array. It's an array of marks. So at position zero, we have a variable that stores the first this is basically an array of people's practical marks, right? Your practical marks, basically the mark for each prac. Prac zero, this it will be at position zero. Prac one will be at position one. Prac two will be at position two. In the array, we're calling it marks. How would you declare that in C++? You basically do it this way. You say int space. Remember, spacing is very important. Space, then followed by the name or the label, or for basically the name of the array, then followed by square brackets, then you specify the size, right, in there. Don't type size. I'm just saying size is so that you can understand. So you have to actually pass a number there. So size has to be an integer because, for example, can you have 2.5 eggs? You can't, right? Can you have 2.5 people? You can't. So like I said, try to understand programming from the real world. So hence, there's going to be an integer number here. We only put integer types here, or an integer number, not floats, not double, no, not decimals. You don't say 2.5 here. It should crash. Let me try to build. It should crash. Yeah, exactly. So you cannot put doubles and floats, all those things. It has to be an integer. In this case, in my diagram, okay, according to my diagram, you see my diagram is three. We have one, two, three boxes, right? So that means it's of size three. But counting starts from position zero. So to get variables at each position, I'd have to say marks followed by square brackets and the position, or sometimes they call it the index. So I'm going to say at position 0. That means I'm now pointing to this box. Then inside of that box, this equal sign, right? It's called an assignment operator because we're assigning or putting something into the variable on the left-hand side. So if I say is equals to 10, like this, and this value that you put needs to match the data type for the array. So the data type is int. If you try to put doubles and things like that, crash. So be very careful of that. So what this line of code does, right? It means go to my array called marks and then index or go into the position 0, assign, meaning put this value 10 into that box. So I'm going to go here, then C++ is going to take the value 10, right? And then it puts the number 10 into this box. So now this box says the value 10. And then you can index at position 1 to put the next value, position 2, put the next value, and so forth. Just be aware of that. So that's the basics of arrays, right? We kind of have an understanding of arrays. To output, remember this is to update or initialize whatever we are doing at that point in time. This is to set the value for that box or for that specific for that position in our array. What about getting the value and displaying it? It's simple. You say cout, the way we've been doing cout. It's max array, but then max array has multiple positions. So I have to specify which position do I want to get. Then I'll say position 0. Then I can put end line if I want to. So this goes to max array, and then it goes to position 0. And then it takes whatever's inside that box, and then it's displayed into the standard output stream. In this case, it's 10. So my output should be 10. If I build and run this, this is going to output 10, right? As expected. So there's 10. So that's how arrays work. You might ask yourself, what about box number at index 1, at index 2? What are the values? Because we haven't set the values. Well, it contains what I call garbage values. So C++ does not initialize anything. You have to initialize it yourself. So let me try to access position 2 and see what's in there. By garbage value, we mean it's garbage. It's a random value. It can be negative 2 billion. It's a random value, very random. Or it can be 0. It's up to you. It's up to the compiler. You see, in this case, it's 0. It happens to be 0. Let's look at position 1. Yeah, you see, it's 16, but I didn't set it to 16 because it's random. So what happens in C++, right? Why is it random? What happens in C++ is that when you create an array, it allocates memory for it, and then it stores it in a specific location. If you had done a previous practical and then you were using that location and you forgot to change it back to 0, and you calculated some average or whatever in a previous practical, what happens is that it takes that average and then it puts it there as a value for that array. So that's basically how computers work. It uses a lot of random values. Unless if you normalize every time you down with the app, you change everything to 0. But then that would be a lot of work. You don't have to do that. That's a lot of unnecessary work. So we understand arrays, right? This is how arrays look. So I'm going to talk about passing arrays in functions. So when it comes to C++, right? Remember, we typically, I'm going to talk about data files. Don't worry about that. So we typically have function prototypes here, right? Right? And then at the bottom here, we have function implementations. We implement, right? We write the code for each function. So here, let's say I have a int sum function, which takes in some array. So you have to specify what array it takes in. So the way C++ works, right? C++ is very old. It's not modern. It's not languages. It's not the same as languages like Python. With Python, it will be enough to only pass the array. In C++, you must pass the array and its size. So you must always pass 2 arguments or 2 parameters. So I have to say the max array, even though we know it's 3, don't put 3 there. Don't do that. That's very spiritual. Don't do such things. But then C++ needs to know what data type this array is. So in a way, it's like you're redeclaring it again. Just think of it in that way. It's like, in a way, it's sort of like redeclaring it again, in a way. And you might ask yourself, why won't C++ complain at me when I've created array with the exact same name? Remember, there's something called scope. This max array, it stops existing when you reach this closing curly brace. So this one at the top here, C++ views it as a different max array. So don't worry about using the same names. As long as it's inside a different function. That it's only part of that function. So the moment you leave that specific function, it's no longer existing, right? It's no longer existent. So for example, you see this function that I'm declaring here, isn't it outside of int main? Yes, it is. So therefore, this max array is different from this one. But then we usually use the same name so that we don't get confused. Because what if you start using weird names like vegetables? Yeah, you start confusing people who are going to read your code. So that's why we typically rename it what it stores, even if it means repeating ourselves. Then you pass in the size. There's two ways you get, okay, there's not two ways. There's only one way. To pass the size, you have to actually pass a variable called length or size, whatever. I wouldn't advise you using the variable size. Why? Because look at what happens. It becomes green, meaning it's already part of C++. So C++ might get confused. You might get confused. Do you mean the size that's part of C++, or you are trying to declare a variable called size? So that's why my size variable, I'm going to call it length, so that I don't confuse C++. Like I said, computers need you to be very explicit. So you're going to have to specify what data type is this length, because it can be anything. It can be a char, it can be a string. You need to specify. You need to be explicit, or another word for explicit is direct. Like just like that video. If you want to talk to me directly. Don't go through the corners. That's C++. It's like that. So you need to tell it it's an int that I'm going to pass as a second parameter. Then you put a semicolon there. So this is what we call the function prototype, meaning when this function is used, what are the things that it expects? It expects an array of integers and an int of type or which represents some length, and it returns, so it gives you back a sum. Then to implement this function, I'm going to talk about header files. Don't worry about that. We're getting there. Then I'm going to have this function over here, right? Then there's the function. I need to calculate the sum. Then to calculate the sum is very easy. Remember, we need to return some integer. So since I need to return some integer, within this function, I'm going to create an integer for that purpose. So this will be, I'm going to call it array sum, right? I can't call it sum again because C++ is going to get confused. It's going to think, am I calling this function? And then that's what we call recursion, which is too advanced in this, by this point in time. You haven't covered that yet. So don't use don't use the same name as the name of your function. It's going to output an error because it's going to ask you where are the brackets. But then you'll be like, no, I don't mean bracket. I don't mean the function. Yeah, well, C++ doesn't care. That's why if you notice, I think Dr. Stung, he likes to put the data type before the variable name, like int sum like this. Yeah, this is outdated. It's a very old way of doing it. So I don't typically use that method. So I'm just going to create array sum, initialize it to 0. So this variable array sum is going to it's going to add up all these values in here and then store them inside this variable over here. So there's multiple ways you can get the sum. I can say array sum like this, and I say is equals to, then I go to the positions, right? Remember, the values are stored at each position. Remember, we have multiple variables at each position. So when you go to that position, in a way, you can think of it as accessing a variable at that position. So that means I can say marks 0 plus marks at position 1 plus marks at position 2. This would work, right? This is fine. But what if I have a million positions? Basically, what if my last position is 999,999? So what if this is my last position in the array? So that means I'm going to write all of those variables one by one. Yeah, not gonna happen. So that's why we pass the length of the array so that we use what we call a for loop, because we need to accommodate for all possibilities, right? For example, the array might be 20 million, might have 20 million positions. Are you gonna type max index 0, index 1, index 2 until you reach 20 million? Are you gonna do that? Nope. So don't do spiritual things. So you're gonna have a for loop that starts from 0, right? This means this basically this statement, right? It means what number will this variable start from? It starts from 0. Why 0? Because our arrays are 0 index. Basically, computers start counting from 0. That's why we're starting from 0. Then where are we going to stop it? Or basically, this is what we call the Boolean expression, right? Or the Boolean condition. Basically, this part will test our loop and see whether we still need to continue going through all the positions. So it should continue running while I is less than length. Why less than length? Because if you pass length and it's 3, that means it's going to say y less than 3. Because if you look at our array, if we start counting from 0, we always stop at the number before the length of the array. I hope you get that, because there's 1, 2, 3, right? 2 is before 3, right? So we always stop at the number before the length of the array. If we had four, positions, this will be index 3. And 3 is the number before 4. So that's why we always gonna say I is less than. Don't say less than or equals to, because you're gonna go out of index, meaning you're gonna go beyond you're gonna go beyond. You see, there's nothing after here. So you're gonna go beyond that. So don't make that mistake. Don't say less than or equals to. Say less than. In this case, the length, and then I plus plus. Yeah, this I plus plus, it means that once we reach this part over here, the closing curly brace. Remember the for loop, it keeps on when it reaches the end of the for loop here, meaning this closing curly brace, it goes back to the top here. Then it starts by incrementing, meaning increasing by 1. The word increment, it means add 1 to that variable. In this case, we're adding 1 to I. Why adding 1? Because if you look at our positions, the difference is 1. If you know sequences and series, the difference is 1 here. So we're always adding 1 to get to the next position. So that's why we say I plus plus. Then we have our array, right? So we need to index into our array. But then now we're no longer putting the explicit position, like position 0, 1, to use I. Because I is going to keep changing. It starts at 0, it goes to 1, then it checks is 1 still less than the length. That's true. Then it accesses. And then it goes back, it increments. Now I is 2. Is 2 still less than 3? Yes, 2 is less than 3. Then it gets that position. And then it increments by 1. Now I is 3. Is 3 less than 3? No. Then this loop stops. So that means we don't ever go beyond the last position, which is good because we're going to get an error. So in order to store this, remember now we need to update our formula a bit. So how do you get a sum? This code will never change, even if you do PhD or whatever. You will always calculate the sum in one way. There's one code to calculate the sum. You create a variable that stores the sum, then you write it like this. You say array sum is equals to array sum plus that number you want to add, which is max at position I, right? Why is this formula valid? Why does this formula work? Let me make an example. So let's say I have the numbers 10, 20, 10, 10, 10, right? And I want to add them to array sum. Using this formula, let's see what happens. So this formula, it says that remember the equal sign right, to the assignment operator. It's called, we say that it's a right associative, right? Meaning it starts doing the things that are on the right-hand side. So it's going to go into this box with that label, take what the value that's currently there, which is 0, right? So this means 0, then add a number. So 0 plus 10 gives me what? 10. Then that answer you get, update that same variable array sum to be 10. So that means array sum now has the value 10. So I'm just gonna put the updates there at the top. Remember, I'm just doing this example to show you why it works. So now array sum is 10. Then we go to the next step. So this will be step 1, right? Then we go to the next step. As long as this condition is true, right? As long as we still have numbers to read, then we do the same code again. Take the current value of array sum. Array sum is currently now what? 10. And then add what? In this case, we're adding 10. Then you add 10. And then 10 plus 10 will just be 20. Then once you're done adding these two numbers, update array sum to be the current sum. Then you update array sum to be the current sum, right? So in this case, it's 20. So that means I'm gonna need to update array sum to the current sum, which is 20. So array sum is now 20. Then we go to step 3. Step 3, take the current value. Remember, when you see an assignment, it always starts with what's on the right-hand side. Take the current value inside this box with the label array sum. The current value is what? 20. Then add the next number in the position, right? In this case, we have 3 positions, 0, 1, and 2. So the current position is 2, so that means we're getting this value 10. So 10, then add those numbers up, it'll be 30. Then once you get a sum here, you add it back to that same variable. You update that same variable to be this new sum. So now array sum is what? 30. So you see why it works. So it does work because 30 is the same as saying 10 plus 10 plus 10, which just gives us 30. But then we wrote it in a code to instruct the computer on how to add. So I hope that formula now makes sense. You always write the same. It will never change. Even if you do PhD, I'm telling you, this formula over here to add, it will never change until you do PhD. And C++ is a convenient way or a shortcut for this. If you have the same variable on both sides, you can just take the first operator, which is this plus, right? And then you put it right before the assignment like this. So this means exactly the same thing as what we previously wrote, but it's like a shorthand or a shortcut, right? So you don't have to write a lot of code. So I know that once this loop is done, array sum will have the actual sum. So I need to return this back to 0 in order for it to calculate the correct sum. Then I'm gonna say return array sum, right? So this will give the person who's calling this function, it will give them the answer. Hence the word return. So return does two things. It returns or gives the person calling this function an answer and also leaves the function. So it does two things. If you remember our session we had when we were explaining this return 0, I did talk about return. So we have our implementation of a function prototype, and then let's test it out, right? So I need to obviously create my array because this function, right, expects me to pass an array. So I need to create my array. Remember, we talked about arrays and having random values. So I need to initialize the array with my own values. So I'm just going to create a simple sum to sum up three tens, which is just what is it, 30. So my output should be 30 is equals to 10. Then I'm gonna see our okay. Then I'm gonna call the function sum. To call a function, right? Remember, you told C++ that expect an array and it's going to be of type int. When you call the function, I've seen people do spiritual things. I've seen people do this. This is very spiritual. Don't do that. You've already told C++ that this function expects an array of that type. You simply just pass in the names of those things, just names or values. That's it. Don't pass anything more than that. And then comma, we need to also put that comma. So comma, then you pass in the length, which is the size. Basically how many things are in the array. There's the size over here. It's 3. Then you put 3. And then this is how you call the function. Simple as that. If you have more variable parameters, you put comma and you pass all the variables or all the values. But then remember, this function gives back an answer. So we need to store it into a variable. What type of answer does it give back? An int. So that means I need to create a variable. So int, I'm going to call it total. Simply, I'm calling it total because if I try to use sum, C++ is going to think I'm trying to call the sum function. Then it's going to output an error. That's why I'm using a different name. I'm calling it total. Then I say see out the total. Then I'm going to build and run. The answer should be 30. Perfect. There's the answer. 30. Even if you increase the number of values in the array, it's fine. It will still calculate the sum because we have a for loop that goes through all the values in the array while I is still less than the length. So even if you pass a length of 3 million here, it will go through all 3 million values and add them. But provided your array is of size 3 million, so that's how powerful a function is. So yeah, just also for loop because we are able to do all of that, all those things because of a for loop. It might take a lot of time though. It might be very slow to output if you put in a size of 3 million. That's why in your practicals, they always use small numbers because it will take forever to run. Computers can actually, you see, when you click build and run, you can load for 3 billion years just loading. That's 100% possible. So you learn in ComSci 3A, there's something called algorithms on how to avoid that for us to wait for 3 billion years while while you're waiting for it to run. There's ways to do that. It's called data structures and algorithms. You do that in ComSci 3A final year. That's if you're measuring in ComSci. So we've used our function. Let's introduce header files. Why header files? I think you can still see the problem here. Look at how simple this app is, and look at how many lines of code I have. 33. And it's a simple app that outputs a sum. What if I have a whole game? That means I might have 400 lines of code. So that's why we need to create separate files for specific functions, right? Then we just import those files. Basically, you see the thing of hash include iostream here. Instead of us creating all the functions inside one file, remember that code. How does it go? Uh, don't lay your eggs inside in one basket, right? If you know that code, you should understand what I mean. Basically, don't do everything inside one place. For example, you let's say you're getting a salary and then you bet all of your salary on Betway. That's very messed up. You don't put your eggs inside one basket. You don't do that. Because what if you lose your whole salary? That means you won't have food to eat the whole month. So that's why we also not gonna put everything inside the main.cpp. The main.cpp should only use functions. Basically, inside main.cpp, you should only have this. No function prototypes, no what. But then how do we achieve that? We create what we call a header file, and each header file that we create, it needs to have its own CPP file. So header files, we store the function prototypes. That's where we put in that's where we put in the prototypes. That's what we put inside the header files. It's function prototypes. Then the implementation file is files that end in .cpp. That's where we put all the implementations for all those functions. So in a way, it's like a header file is like a promise, right? So to create, okay, before I make that example, I always use the same example to explain header files. So to create a new header file, you click on File on the top left corner, then you select New, then you select File again, then File, then you go to Files. By default, it's gonna be on Files. You don't have to worry about this. By default, it's gonna be here. Then you click on C or C++ header. That's the header file. Then you click Go. Then you might show this. Just make sure you select skip so that it doesn't always show this every time you want to create a header file. Then you click next. This is a very important step. Then you give your header file a name. In my case, it's a, let me call the header file math, right? Because we're doing maths related stuff. Maybe I can also do an average. So maths related stuff, I'm gonna create two functions, a sum function and the average function. So maths, you can also put in the extension here. So you say maths dot age. Then C++ is not that wise, right? Like I said, the computer you need to be explicit. You need to tell it things. So you need to click these three dots here to include or to tell code blocks to add this header file into your project, or else it won't add it. So you need to click those three dots here. Then you don't have to change anything. It's already automatically code blocks goes to the project folder. Basically, the folder of the project that you have currently running inside code blocks. By default, it goes there. So you just need to click those three dots and then click save. That's all you have to do. Then you'll see that it's going to append the full location. Then for me, I don't like to put the underscore included part. So I usually remove that. That's a preference because I was taught by Prof. Coulter. That guy is the GOAT. He's still at UJ, but he teaches Informatics 100 now. But yeah, I usually follow his way of doing things, which makes sense. Because why do you want the underscore included? So it should just be math underscore h. Then here, you see this part here, very important, this part. If you just go straight to finish, your code won't work. So you need to click all so that if an error is there in your header file, C++ will tell you. I know it sounds good when you're not told errors, but trust me, it's not good because you convince yourself everything is running. Then you submit. Then on the tutor's side, on the computer D labs, on the computer labs at the LS4, yeah, they try to run it and then it crashes because you didn't pick them up. It didn't show you on your side. So we're gonna need to click all so that we can get errors if there's an error. Then you click finish, then done. And then you keep on redoing this step, you'll see you're gonna have multiple. In second semester, your files are gonna end up somewhere here. That's how many files you're gonna have. Somewhere here, sometimes even there. So yeah, guys, attend class. If you guys think school is like university is the same as high school, you can freestyle. Okay. You tell me once you've failed, or you tell your classmates next year once you're repeating the same module. Then I'm gonna need to create a namespace. So a namespace, okay, what is a namespace? So a namespace, let me make it simple, a namespace, right? A namespace, remember, the C++ complains when you declare the same variable twice, right? In C++, we can force C++ to allow us to create names that are exactly the same. So for example, I create a variable called cin inside a different namespace. So, okay, let me go back here. I'll undo that because for a practical, you must use namespaces. So I need to explain namespaces. So, and then I have the same variable with the exact same name. If you try to use them as they are like this, your code is going to show an error because it's going to say, wait, which one? Which one is which one here? Like it's like the Spider-Man meme when they're pointing at each other. Who's Spider-Man? Who's the real one? Who's the fake one? Because we're all Spider-Man. So that's the problem that it arises, right? When you name things the same way. But you can avoid that. You can tell C++ to allow you to use the same name by using namespaces. So a namespace, you can imagine it's a specific storage area. So this will be this will be now inside this storage area, or basically let's view namespaces as toolboxes. So this will be now inside this specific toolbox. Then you're gonna have another toolbox, and then you're gonna have this the exact same tool, right? This the exact same tool. It's like if for 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 the ladies out there, I know you might, well, everyone knows what a toolbox is, but for the ladies out there who don't know what a toolbox is, think of it as like your pencil case or your purse or something. You can put your lip gloss. You can buy the same lip gloss, right? But then if it's inside two different purses, then it's two different lip glosses, right? You're not gonna confuse them, right? So it's the same thing. For gents, you can think of it in terms of toolboxes. So this will be, for example, this is STD, right? That's the name of that toolbox. Then we're gonna have a different one, maybe my own name. I'll call it EA space, right? That's my toolbox, right? That means now when I use these tools, since they have the same name, I must always specify which toolbox am I getting these tools from. So that means I can actually use the same name. So that means I can say standard colon colon. It means that this toolbox go inside of it. These two colons, they mean go inside the toolbox with that name and fetch me this tool. Then I can also use the same name, but then remember I specified the two boxes. So C++ says, listen, it's fine. I can allow it because it's two different boxes. It's two different two boxes, right? So here I can say C in again. So you see, it will work. So I can say C out this way, then I can say C out that way, right? It knows that these are two different C-ins, right? Because it's in different namespaces. So namespaces allow us to do that. So that's why in your practicals, they want you to use a namespace. So to create a namespace or to tell C++ to define a toolbox for you, you just simply say namespace followed by a space, no pun intended. Then you give it a name. So I'm gonna call it math. Okay, let me just call it math um, space, right? That's what I'm gonna call my namespace. Then you put in the curly braces here. Then you specify the things that are part of that are going to go inside of that toolbox with this name, right? Then I'm just gonna say this is the function. You can inside this namespace, you can put in a function, you can put in variables, you can put in constants, you can put in anything in there. But then inside the header file, like I said, we only put in prototypes. Don't write any implementation code here, or else it's gonna crash. So be very careful. Then once you are done putting all your function prototypes, you create another file again. This time around, you're creating a C++ source file, or in other words, implementation file. Then I'll double click on that, and then I'm gonna select skip this next time, choose the programming language. We're doing C++. Then you give it a name. It's 100% advisable to use the same name you've used for your header file. The only difference should be the extension. So the header file, it ends in a .h. The CPP file needs to end in a .cpp. Look at the capitalization. I've capitalized M. Also in the header file, capitalize M. They need to be exactly the same name. That's why in the practical, they also ask you to create a header file and the CPP file with the exact same name. So else it's not going to work because we want to link them. Then I'm going to press the three dots and then just click save so that it saves this file inside of my folder or inside of my project. Then you select all. Don't forget to select all or else it's not going to run. Then you click finish. Then now, inside of your CPP file, you include the header file that is the function prototypes. I did talk about this in the first session for intensive revision, that when you created your own header file, you use double quotes. When you're importing something that's part of C++, you put angle brackets. So don't mix them. So I've created my own header file. So I'm going to use the double quotes. So math.h, but then everything is inside a namespace. So I have to actually redeclare that same namespace. So math space, then I need to implement my function. So my implementation is this side. I'll just copy and paste so that you see why we're doing this. And then copy my implementation. Now look at your main.cpp. It's empty. It's just simple. It's just so elegant now. That means you can have 100 million functions. They'll be hidden. They'll be stored here and implemented here. So your main.cpp, it ends up looking neat. Then I'll just align this so that it's aligned. Yeah. So this is the namespace. There's my implementation. Then now inside, remember, it's part of the namespace. Inside of my main.cpp, I need to include that header file. You only include the header file. Trust me, C++ knows how to link the implementation with the function prototypes. You don't have to worry about how it does that. You must only include the header file. So math.h. So now you've told C++ to include everything that's inside math.h. So what this does, right, remember we talked about it in the first session. It literally just copies and pastes everything inside of that file. So it goes to this line. Oh, you want me to copy and paste everything inside of the line? Okay. Then the preprocessor does that. It copies and pastes everything. So it literally does that for you. You just write one line. But then after copying and pasting, remember the function we're trying to call is inside a toolbox. So there's two ways we can do that or call the function. If I leave it like this, it's going to crash because it's going to be like, what do you mean? Where's sum from? There's the first approach, which is to specify which toolbox are you getting this tool from. So I can say math space colon colon. Then now when I try to build, C++ is not going to shout at me. But then you see that this is annoying. Every time I have to say math space colon colon, I have to always do that. You can tell C++ that you will use things from that toolbox. So you literally use the word using because you're telling C++ that you'll be using the tools from that namespace. So you need to say, I'm using the toolbox or the namespace math space. So that means now this is now optional. You don't have to specify the namespace. You can just say sum. C++ will know because you said using namespace. Then you're going to build and run. And then see, it still works. The sum is still there, so it's still correct. But then now it's working perfectly fine. So this is basically how they want you to do the break. So you're going to have to create your functions in here, the function prototypes, put them in their specific namespace. Then you're going to have to do the implementation for each function prototype inside its own CPP file. Or it's sometimes called source code or source file or implementation file. As long as it ends in a .cpp, that's where we're going to put implementations. So yeah, that's pretty much all you have to do. Then for the practical, let me explain a bit about the practical, right? So that you understand the problem. Okay, I'm gonna have to be late, Nyana, for the ComSci 2A session. So the mutation, right? With mutation, I'll just explain it to you and give you the formula because yeah, I'm sure you guys are tired. Just wanna do the preg, go to recess, but then remember recess, we're still having sessions. So what mutation does, right? If you understand life science, you can explain it a bit better. But in this case, mutation, because I never did science, so I don't know. You guys know better if you did life science. You know, but then I know what mutation is. But I'm just saying, from a life science perspective, you'd understand a bit better. So uh, in simple terms, what mutation means, it means something to, in a way, evolve to become something else, right? So it's like to change. So it's like, for example, you had a friend and then that you trusted very well, and then they backstabbed you. And then you're telling people, you're like, hey, this person, he just changed. I don't know, he just changed. You can remove that word change and say he just mutated. That means he became something else. So that's what mutation is. In this case, the formula you must use for mutation is that you're going to go through all the positions in the array. I demonstrated that using a for loop. This is how you go through all the positions using a for loop. Then you're going to check the value. Okay, you're going to check the value at that specific position. If the value is a 1, you change it to a 0. By convert it to a 0, they mean assignment. Basically, this is literally what they mean. You're going to say if marks at position I is equals to 0, then marks at position I should become a 1. Simple. That's literally what they mean there. And then you check if marks is a 1, then you change 1 to a 0. So that's literally what they're telling you to do. That's the mutation formula. As you can see, it was a 0 here, it became a 1. It was a 0 here, it became a 1. It was a 1 here, it became a 0. So it mutated. So you're going to go through all of the positions and do that. That's mutation. Mutation is easy. The part that's a bit tricky is the recombination. So recombination, you take in two arrays, but then remember the practical, they said, let me see. Yeah, they said each array, right? So they said each array in the population will be of the same size. So what they're telling you is that when you create a function that takes in two arrays, right? For example, you have int, and then you have array 2, and then comma. They mean just passing one length because both arrays, they share the same length. That's literally what they're telling you to do. They are the same size. So don't be passing 4 arguments or 4 parameters. It should be 3. So you're going to take in two arrays, right? There's your arrays and the length. Then, not just the length, there's also index and an index. So you're going to pass in 4 parameters. So you're going to have the first array, comma, the second array, comma. Then to be honest, it doesn't matter the order you create the functions in. You can start by passing a length. It doesn't matter, as you need to be consistent with your code. You know your code. You need to be consistent with your form, with the way you've structured your code. Me, the way I would do it is I'll pass the first array first, comma, pass the second array, comma, pass the length, comma, pass the index. So that's 4 parameters. Yeah, let me see. Do you have to pass let me think about it. I don't think you have to pass the length. Yeah, I think I need to double check that. I don't think you have to pass the length. Yeah, you don't pass the length. So it's 2 arrays and an index. Yeah. No, don't pass the length because the way you're supposed to recombination, the way it works, right, is that you take in an index, then you're gonna go through the loop and then use that index as a stopping point, right? So that means if the index is 2, meaning, so let me show you the diagram. So if the stopping point is 2, that means in your loop, you're gonna, instead of saying I is less than length, you're gonna say I is less than or equals to index because you want to stop at exactly index. That's why I'm saying equals to. That's what the practical says. So that means you're gonna always start at 0, but then the index is gonna define our stopping point. Then we start from 0, 1, 2. Let's say the stopping point is 1. That means I'll stop at exactly 1, starting from 0. That means I'll only look at or only focus at 2 positions. So once you focus on 2 positions, what must happen? Swap the values from the first array to the second array at each position. So the value at position 0 should become this value 1. As you can see, it's now 1. And then the second value 0 should become a 0, still a 0. So 0 is here. And then this value 1 must become 1, which is still 1. So you see these first 3 values, they swapped. If you've noticed, they were inside array 2. They are now inside array 1 because our stopping point was index 2. The user can specify a different stopping point. To swap, right, I'm running out of time. I'm sure my ComSci 2A students are waiting patiently. They're asking in the group, they say the session. So to swap values, this is how you do it, right? Let's say you want to swap values from at position 0 and position 1. So let's say position 0 is the value 12. Then position 1 has the value 3. And you want to swap the values. So to swap, some of you might think, oh, it's simple. I just say it marks index 0. I take the value at index 1. Then and then I'm almost done. Then I take the max value at position 1 it should now become the value at position 0. So this is what I do, right? You think, you've done it. Let's try to replace the values, right? Let's try to do exactly what's done here. Remember that C++ reads from top to bottom. Just keep that in mind, top to bottom. So it's going to read line 4, it executes it, it runs it, then it moves to line 5. Just keep that in mind. So max 0 is going to have to become this value at position 1. The value at position 1 is what? 3. So that means in a way you are telling C++ to initialize this to a 3. Then it runs line 4. So that means at position 0, the value has been updated to become a 3. It's no longer 12. It's now 3. Then at position 5, okay, let me just put it back here. I'm going to update the values at the top. So position 5, I take the value that's currently at position 0, which is 3. So I hope you see the problem. So that means I have 3 and 3 here. So I didn't swap. What happened? Well, what was the problem? Well, I lost track of the value at position 0. That was the problem. So what you need to do is before you update the value at position 0 or whatever position, create a variable or that stores the term, or it keeps it keeps a copy, right? It keeps a copy of the value. So max at index 0, right? So that variable copy, it kept track of the value 12, right? So that means this actually has the value 12. So it has the copy. I'll just make it as a comment 12. Then I'll just change the language to C++ so that it highlights. So it's now 12, right? Then now I update. So max at position 0 takes the value at position 1, which is a 3. Then I try to change max at position 1, which becomes 3 again, but then no, I don't want it to become 3. I want it to become 12, of which 12 is stored inside the variable copy. So that means I have to actually use copy here. So now it's perfect. This becomes a 3, and then this becomes a 12. So swapping has executed successfully. So this is how you swap. Even when you're doing PhD, still the same formula. Just always keep track that you need to make a copy of that value before you update that variable. Then after update it, when you want to change the second variable to be the first variable, you just use the copied value. Because at line 6, C++ has already updated the value position 0. It's now 3. I can't store 3 into 3 again. It's already 3. So you get what I'm saying? You can't do that. So this is the formula to swap. And this is what they want you to do. They want you to swap. In this case, I'm going to give you the formula, right? I'm going to give you the answer, but I'm not going to write it as a for loop here. I'm going to show you the answer. If you are good in understanding things, you should see that I actually gave you the answer. Remember, they're of the same size, meaning that they're inside the same for loop. So that means they're using the same index or the variable I, right? This I variable. They have the same variable. So I'm going to use I. So you're going to have to create a copy. And let's say you have array 1, right, at current index I. Remember, changing at every single position. So that's why I'm using I. So I need to swap at every single position. Then I update the value at position I to be the value at position I from the second array. So I have to say array 2, right? Because we're swapping the 2 arrays. The formula is still the same. The only difference is that I'm working with 2 arrays. That's the only difference. Then now I need to take my value at position array for the second array, right? At the index I need to make it to be the copied value. Then I've successfully swapped between the 2 arrays at every single position I. If you are paying attention, I actually gave you the formula for the preg. If you are paying attention, when I was explaining the index, that you should say I is less than or equals to index. That's actually the answer for the preg. So if you can pick up on hints, I gave you the answer for the preg. So this is how you do recombination. It's basically swapping values. That's a recombination. Then I gave you the answer for mutation. I even wrote the code. I canceled it, but I wrote the code. You should understand how to do the preg. To be honest, you should actually finish the preg today before you sleep, because I gave you everything. So this is it for today's tutorial. We'll continue with our intensive revision, right? Now we have to talk about output, right? in our next tutorial, output and variables. But I did touch on variables a bit. Yeah, this is variables a bit because it's just the box. That's a variable with a label on it. So good luck with your practicals. And don't forget, you can ask questions in the group if you get stuck on something or if you have an error. You can ask me in the group. Hope you guys have a lovely evening.